In this lesson, we are going to talk about direct variation. And when you think of the words direct variation, we're varying directly with something. Okay, and that's what it says right here. Two variables, x and y, vary directly if there's a non-zero number k, that's our constant, such that the following is true. Y equals k times x. And it says here that k is this constant of variation. Now I know that's a bunch of words that probably don't mean a lot to us, and we're kind of wondering what this equation means. But if you think about it, this k here, let's just say this k was 2. That means whatever number we put in for x, y is going to be twice that number. So if I were to put in a 1 for x, I'd get 2. Y is twice of x. If I were to put 2 in for x, I'd go 2 times 2 and get 4. 4 is 2 times what 2 is. Or, I'm sorry, y is twice of what x is. If I were to put 10 in, 10 times 2 is 20. So, again, whatever our y value is here, that is twice of what x is. That's why we say y varies directly to x. Okay? Varies directly by this constant. Let's look at an example. It says find the constant variation in the slope of the direct variation model. Y equals negative 3x. Alright, let's just look at this simple equation, because again, this is just an equation and function. We're just changing our terminology. It says find the constant of variation. Okay? Well, we want to know how much our solutions are changing every single time. So again, if I were to make an input-output table, I could say if I put 0 in for x, I get 0 for y. If I put 2 in for x, 2 times the negative 3 is a negative 6. If I put 4 in for x, 4 times the negative 3 is a negative 12. So what's happening from our x's to our y's? Okay? Well, we're multiplying by a negative 3 every time. So when we say what is our constant of variation, we're saying what constant, that's just a number, by how much are we varying every time? I'm sorry, these are negative 3's. Well, we're varying by negative 3 every time. So our constant of variation is negative 3. You don't need to make an input-output table to do that. Remember right here, this is an equation for a direct variation model, and it says the number k is the constant of variation. So basically, whatever our coefficient of x is, that's our constant variation. You didn't need to do any of this work. You could look at this and say, oh, the coefficient of x negative 3, that means y is always going to be whatever x is times negative 3. It's our constant of variation. Okay, again, just kind of weird terminology. So our constant variation is negative 3. Our slope now we have to figure out. Now, you could make an input-output table, so pretend I didn't cross this out. And if we wanted to plot the points on the coordinate plane, I could plot the points 0, 0, 2, negative 6. So I go over 2, down 6. And I'm going to run out of room to do the next point. But what you can see is that we get a line that looks like this. So if we wanted to find the slope of this line, there's a bunch of different ways we could do it. We could think of it in terms of rise over run. So from this point to this point, I'm rising negative 6, and I'm running 2. So we get negative 6 over 2, which divides out to negative 3. You could use the points 0, 0, and 2, negative 6. And again, you could use 4, negative 12 too. I just didn't have room for that on my graph. And if we use our slope formula of y2 minus y1 over x2 minus x1, I'm going to say my difference in my y's, so negative 6 minus 0 over 2 minus 0. Oh look, we get negative 6 over 2, which also reduces to a negative 3. So do we need to do all of the work to figure out what slope is? Honestly, no. Your constant of variation is going to be your slope. So if you have a problem that says find the constant variation and the slope of something like this, well, this negative 3 here, it's your constant of variation. It tells you how much y is going to vary every time with x. and it's also going to be your slope. Okay, so the constant of variation and the slope end up being the exact same thing. Okay. Now let's look how we can set up an equation when we're given an x and y value. It says the variables x and y vary directly. That's really important, that term right there, vary directly. Because remember right here, two variables x and y vary directly if this is true. So as soon as you see the phrase vary directly, you think y equals k times x. Now what we want to do is we want to find out what our constant of variation is. Okay? So stick with me on this. It's not hard to do, but I know sometimes it seems weird. It kind of seems almost repetitive. But it says write an equation that relates x and y. We're focusing on the term varies directly. We see varies directly, we think this equation. Plug in what you know. X equals -3. So for x here, I'm going to put in a -3. Y equals -30. Okay, so for y, I'm going to put in a -30. I don't know what k is. I don't know our constant of variation. I just know what my x and y is. So I have an equation. I can solve for k. I can divide both sides by -3. And I'm left with k equals -30 divided by -3 is 10. So our constant of variation is 10. Okay, look at this equation right here. This is a direct variation model. Y equals -3x. When you have a direct variation model, it should look like this. So you can plug in whatever x you want and get whatever y you, when you plug in x, you get whatever y is. So what you have to do, ladies and gentlemen, is you stick this k here back into this equation. So your solution here, your equation that varies directly, is y equals 10k. I know it seems kind of weird because we plug numbers in for x and y to get 10, and now we just put it back in, and the answer is yes, because now when you get to this next part here, find the value of y when x equals 8. We know, I'm so sorry I wrote this wrong over here. This should be an x. Sorry about that. Okay, so we want it to be y equals 10 times x, because now I can take this 8 and plug it in for x and know what my y is. Okay? So when it says two variables vary directly and they give you what those variables are, solve for your constant of variation and plug it back into your direct variation formula. And down here, if I want to know what x is, I want to know what y is when x equals 8, I just substitute 8 in for x, and y is going to be 80. What this equation here means is that y is dependent on this x. It's going to vary directly by the x. It's actually going to always be 10 times x. So again, when you're given an equation, a direct variation equation, think of y equals k times x, where k is your constant of variation. When you're given what your x and y are, solve the equation, substitute and solve the equation to find out what that constant is, and then plug it back for k in your original equation.